A mixture of ammonia and N2H4, both gaseous, is placed in a sealed container at 300 Kelvin. The total pressure is 0.5 atm. The container is heated to 1200 Kelvin, at which time both the substances decompose completely according to the equations. 2NH3 forms N2 plus 3H2 and N2H4 forms N2 plus 2H2. After decomposition is complete, the total pressure at 1200 Kelvin is found to be 4.5 atm. Find the mole percent of N2H4 in the original mixture. So let's say that the original mixture had X moles of N2H4 and Y moles of ammonia. Okay. So basically, for the original mixture, the ideal gas equation would be PV is equal to nRT. The pressure is given to be 0.5 atm. Volume is V. N is X plus Y into R into the temperature is 300. Okay. Now, as soon as the temperature is increased, decomposition occurs. So, the reactions for decomposition will be ammonia forms half N2 plus 3 by 2 H2 and N2H4 forms N2 plus 2H2. So, when we had Y moles of ammonia, it would get completely decomposed into Y by 2 moles of nitrogen and 3Y by 2 moles of hydrogen. And similarly, in the case of N2H4, when we have X moles, this would get decomposed into X moles of N2 and 2X moles of H2. So the total number of moles we now have in the mixture will be 3Y by 2 plus Y by 2, that is 2Y, and X plus 2X, that is 3X. So these are the total number of moles we now have. So the ideal gas equation now would become the final pressure, which is given to be 4.5 atm, right, on increasing the temperature, into volume. All of this is happening in that very same container, is equal to N, which is the total number of moles, that is 2Y plus 3X, into R into the temperature, which is given to be 1200, right? So let's just divide both these equations. The second one being 0.5 V is equal to X plus Y times R times 300. Okay, so when we divide both of these, V gets cancelled out and this gives a 9. R gets cancelled out, this gets cancelled out, and this gives a 4. So multiplying, we get 9x plus 9y is equal to 8y plus 12x. And we can write it as y is equal to 12 minus 9, that is 3x. So we have got a relation between the number of moles of ammonia and the number of moles of N2H4. So let's say if the value of X is taken to be 1, that is, we have 1 mole of N2H4. So the number of moles of ammonia would be 3. So the fraction of the number of moles of N2H4 would be 1 divided by 1 plus 3, that is 1 by 4. And if converted into percentage, this would be 25%. So basically, 25% of the original mixture was N2H4. And so our answer becomes option B.